Upward Bound Math Analysis Day 2 is combinations and composites of functions, including domain and range. So first of all, let's talk about functions. A function relates each element of a set with exactly one element of another set, or possibly the same set. Each element means that every element in X is related to some element individually in Y. Exactly one means that the function is single valued. It will not give back two or more results for the same input. So function terminology is read f of x, and it equals something involving x, means a function is a relationship involving the variable x. Essentially, they changed y into f of x. The domain is the x values that you plug in, and the range is the f of x or y values that you get out. So the sum of f and g is literally combining like terms. But now, instead of just writing it out as combining like terms, we're going to say f of x is equal to 2x squared plus 3, and g of x is equal to x to the, or 4x to the third plus 1. And you do need to combine like terms and put them in descending degree order. So that's why the 4x cubed goes first, 2x squared, and then 3 plus 1 is 4. Then you also have the difference of them. To find the difference, be sure that you distribute the negative. Okay. And again, it's just combining like terms, but again, be careful of the negative and be sure that you put them in descending degree order. Multiplying two functions, again, is FOIL. Good idea to put them in descending degree order, but is not required, but it would be helpful. Then you have the division of them. Believe it or not, nothing can be done when you have nothing that matches and nothing that factors. It's going to simply be what it is. The composition of functions means literally substituting one function into another. So in this, we read f composition g. It means to copy the function f down, but where there's an x, you're going to substitute g. Okay, so f of g of x literally means take this x out and put in this equation and simplify. F of g of x. And it can be written one of two ways. It can be written like fog almost, or it can be written f of g of x. Okay, showing the substitution. FOIL first, then distribute the 2. Okay. Again, g of f of x, it is putting f into the g function where x is and simplifying. You could multiply this out, but since it's to the third power, I'm not going to do it. Sometimes you will be asked to find f of x or g of f or g of g. And that is literally putting the function into itself and simplifying. Now, the domain of a composite function, the domain of f, composition g, is the set of all numbers x in the domain of g such that g of x is in the domain of f. That's just a wonderfully fancy way of saying you're definitely going to have to figure out what you can and cannot put. Meaning, down here at the bottom, you can't divide by 0, so you can't put x cannot be 1. It's got to be anything greater than 1, because you also can't have an imaginary number down there. Okay, the domain of g is greater than 1. So therefore, we also have to worry about any illegals in this composite function. So x cannot equal 1. So the domain would have to be anything greater than 1. G of f of x, determine the domain and the range. The domain cannot be, is given over here. The domain is all real numbers except for 6. The range would be all real numbers except for 0, because you won't ever get 0 out of that function. Domain and range of composite functions. Again, be sure that you look at the domain of the original function. The g of x cannot equal 1, so neither can the domain of the composite. And the range, you would never get anything, you would never get a -5, because you can't have 0 as the denominator for the g of x function. Finding f of g of x and determine domain and range of the resulting functions. Again, same thing. The domain is drawn from the f of x function, cannot be negative, so it's got to be greater than 0. It does too with the composite of both of those, because that would simply be x. However, even though g of f of x would equal x, it is not all real numbers for both, because you do have to take into consideration the original 2 functions. All right, we'll do several examples in class. Thanks for watching.